should be able to do what he calls 10-second hypothesis tests. When you see Minitab output, you should be able to look at this immediately and say, okay, I'm doing a hypothesis test to see the effect of salary on wins, and that p-value right there tells me whether wins are significant or not. I'm sorry, salary is significant or not. What am I looking for in that p-value? I want it to be small, less than alpha to indicate significance. Now, at this point, I do still want you to do HO, write down your t-stat, your p-value, and tell me, reject HO because 0.002 is less than 0.5. But we're getting to the point now where you should be able to just look at computer output and kind of figure out, yeah, more money means more wins, and yes, it is significant. How much of an effect? An extra $1 million of salary is about 0.23 more wins. All right, so regression, this is, the by hand part, you need to be able to do your V1, V0. Outside of that, there's really not a lot of computing. So at this point, it's becoming more interpreting and using output more so than actually computing numbers. And the same thing is sort of true, in my opinion at least. Remember, this test also covers ANOVA. And in years past, this is just from memory, in years past, I have often, for ANOVA stuff, I don't think this is what I wanted. No, I'm pretty sure that's not. There was my ANOVA homework. There we go. So there's the PDF. So in years past, what I have done quite often is I will give students the first part of the ANOVA table and then have them fill out the rest of the ANOVA table. So computing is not the big thing, it's just do you know how to fill out the rest of the table? And I usually have the other things labeled, like the next thing would be degrees of freedom. The next thing would be mean squares, F-stat, F-critical value. So just look back at the examples we've done on that. Make sure you can fill out the ANOVA table and test for a difference in these four methods. I do also realize that I've been, let's just say, slow on getting stuff graded and handed back to you. That always happens. In an attempt to help with that, though, okay, that's not, where did it go? That's why I put this on here, but it's not going to open. There we go. I did go ahead and, okay, that's not what I wanted. This was the ANOVA from chapter 12, the Minitab ANOVA stuff with my answers and, talking about the different results. I might give you Minitab output for ANOVA. I'm more likely to give you Minitab output for regression, but I could give you something like this for ANOVA and have you test something. But what I was really wanting to show you, I did this by hand and just kind of scanned it. This was me working out the ANOVA problem by hand. That was your homework from chapter 12 or whatever. You had 4 different production methods. The first thing I did is I averaged those 4 production methods. Then I went down here and I filled out the rest of my ANOVA table. This is what I would be asking you to do on the test probably. You would have a table with this first column numbers given, and then you need to fill in the rest of this column and do the test. What does that tell me? The F-stat is bigger than the F-critical, so I will reject, well, I've got it written right there in blue. You will reject HO and accept HA. And what does that mean? Remember, what question am I asking with ANOVA? Only one question with ANOVA. Is there a difference in the average whatever for method 1, 2, 3, and 4? And in this case, I rejected HO, so that tells me there is a difference. Given that there is a difference, what is my next logical question going to be? Where is the difference? What's different? And that's when we do LSD things. And I went ahead and I told you long ago, I'm not going to make you compute LSD. If I want you to use LSD, it will be kind of like this. I will give you LSD And then you'll do these individual comparisons and see which ones are different, which ones are not different. How do you tell if they're significantly different? Is the difference bigger than 4.75? If the difference is absolute value, don't worry about positive, negative. And that's why, remember, that's why I went ahead and did these averages first. How far apart does it look like method 1 and 2 are about 12.6? Is 12.6 bigger than 4.75? Yeah, then I would say 1 and 2 are significantly different. So that's what the second part of this problem is doing with the LSD stuff. So by hand, this would be kind of it. Now, also in Minitab, I do have posted a randomized block ANOVA example.
What is this test?
Monday.
Is it really Monday? What?
You can keep asking and it's not going to change. You're in better shape than the guy in my Stats 1 class, though. He showed up test day, and I told him to move because he was sitting right next to somebody. He said, "What, do we have a test today?" And I said, "Yeah." He was like checking to make sure he wasn't naked. You know, he was having that dream. So see, Sean, you're in good shape. You've got like 5 days to prepare. I did go ahead and put a randomized block example, and you can read through the example, and I kind of set it up for you here and tell you, again, sums of squares are given. If you have 2 explainers, remember that's when you use randomized block. You have 2 explainers. The number of explainers for device, or the degrees of freedom for device, is how many devices did I have, minus 1. Patient, how many patients did I? Anyway, I'll walk you through how to do a randomized block as well. But remember, guys, honestly, if you can do, and I see this happen and it bothers me, but if you can do this table, if you can fill out this table with 1 explainer, you should be able to fill out randomized block. I mean, the only difference is it's going to have 2 explainers here. You'll have 4 sums of squares instead of 3 sums of squares. But still, you do the same thing. You just divide across and fill in. So basically, I've got a bunch of stuff on Blackboard that I think if you will go through that for ANOVA. Remember ANOVA, there's 2 types of ANOVAs we did. Just the one-way ANOVA and then the randomized block ANOVA. Well, I've got examples of both those posted on Blackboard for you. With regression, I've told you what you're going to have to do there. You're going to have to do a by hand B0, B1, come up with your y-hat line, and then you're going to have to do some stuff with Minitab output. And that's about it as far as problems go. Now, I'm also going to ask you lots of questions. Why, explain, sorry, but I think that's important.